Welcome back, ladies and gentlemen. This is new, right?
Yep.
Newton's second law of motion. Write this down. It says acceleration equals the F net, which is the net force, divided by mass. Write that down.
Right. And this actually is a big idea. It's an equation, but it's a big idea that you probably know already.
And so let's talk about these words down here. It says more force equals more acceleration. So what that means is if you have more force, you have more acceleration. If I push something with more force, it's going to accelerate faster, or it's going to accelerate more, right?
Yeah, and what you've got is a fraction there, and if the number on top of the fraction gets bigger, the whole number gets bigger. That's right.
But what about the bottom? If the number on the bottom gets bigger,
The whole thing gets smaller.
and what we mean by that is if we have more mass on the bottom, we have less acceleration. Now think about the book, right?
Yeah.
The book had more mass than the notebook, and so it was harder to accelerate the book,
Yep.
right? I just realized we could have done the golf ball, bowling ball thing.
We could pause it and put it together.
Let's do it. So now that we've got our little experiment set up over here, I have two. I have a ping pong ball and golf ball.
Yeah.
And what I'm going to do is I'm going to whack it with this hacksaw blade that I've attached to a block over here.
Yeah.
And we want to be thinking about how much force, how hard I'm hitting the ball with.
How can you change that with the hacksaw blade?
So it'll be more force, I'll pull it back further.
Yeah.
Less force,
Don't
less
pull it back.
further.
Oh, okay.
Right?
It's like a rubber band if you're going to hit somebody with a rubber band.
Exactly.
Not that you would ever do that.
And which one of these has more mass?
Golf ball, ping pong ball.
Okay, golf ball has more mass. So, all right, here we go. So I'm gonna go ahead and hit this golf ball, the ping pong ball with a little bit of force. Okay. Now, that was kind of
back
weak
over
sauce.
here.
It didn't really go, I hit it with only a little bit of force. It didn't accelerate very fast. It didn't go very far. It didn't accelerate very fast. Now, I'm gonna hit with more force. What's gonna happen to the acceleration? Boink!
Whoa!
That was cool. That's not how it went when we practiced.
No.
Okay, so now we have golf
golf
ball. More mass. I'm gonna hit it with only a small amount of force.
What?
Oh, okay.
Do that again with a small amount of force. That's weak.
Weak sauce.
Okay,
now-
more mass. It didn't even move. Now, slap that sucker.
Boink! Oh.
That did not go very
more
well.
force, more acceleration. Boom. And that's all there is to it, right? So we see that the more force you hit it with, the further it accelerates, but also the more mass you had, the less it accelerated. And we had this golf ball which had more mass, and it didn't accelerate as fast as our ping pong ball.
That's right. Newton's second law of motion.
There it is. And again, this is stuff you guys know. We're just putting an equation to it.
Yep.
Okay, so this is how we typically see this equation. You typically see it as force net. The net force equals mass times acceleration, where acceleration is always in the same direction as the net force.
Oh, yeah.
We've heard that before.
Yeah.
The units of force come from Newton's second law. So force is a Newton. Newton, not Newton. Newton.
Mutant. It's a mutant.
It's a mutant. And then mass is a kilogram and acceleration is meters per second squared. So if you ever see all of these mumble jumble letters together, it equals an N, a Newton. Newton. I'm thinking about big newtons. Okay. A free body diagram is a dot with arrows drawn to represent vectors. Y'all remember these?
Yeah.
Let's think back to our bubble cart. This guy right here. Okay? And my question for you are, what forces are acting on a bubble cart when it is at rest on the table? So what I want you guys to do is, I challenge you, don't look in your notes. Okay? Try to do this from memory. Before we did rest, push, and coast, right?
Yep.
Okay, this one's asking you to look at rest. What forces are acting on a bubble cart when it is at rest on
Now, how do you
the
draw a
table?
free body diagram?
So
What do you
it's a-
start with?
So we want to start with our dot, right?
Oh, a dot.
Our dot.
Dot.
Dot. And go ahead and do it. Give it a try. Pause the video. Okay. Check your work with me. First thing we're going to talk about is the force of gravity that is pulling the cart down towards the center of the earth.
All right.
Right? So I'm going to go ahead and draw that like this. Force of gravity. And
It's not falling though. Gravity is pulling it down, but it's not falling.
it's not falling. That's because the table is pushing back up. Right?
If it rolled off the end of the table, the table wouldn't be holding it up anymore.
And it would fall. We're going to call this the fuck.
Fuck.
Force up. Okay. Now, when it's just resting there, are there any other forces?
Nope.
Nope. Okay. Let's see what my next slide says here. While you are pushing a bubble cart, what forces are acting on it?
Give it a shot.
Try.
On your second dot. Give it a
Start
shot.
with a dot. Dot, 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 dot. Okay, while you guys are doing this, I'm going to go ahead and start working on it.
Some things will be the same as when it's at rest. Something will be different.
Okay. Got my force of gravity in there.
Force of gravity.
Okay, what else is the same? Well, it's still not falling, right?
That's right.
Okay, the force of gravity is pushing up, keeping it from falling. But we're pushing it now, right?
Yep.
And when we push it, we're pushing it that way. Okay, and we're gonna call this the force of push. Oh, I wanted to talk about the bubble. Bubble's in the middle right here, right?
Yep.
And when we push the bubble goes in the direction of acceleration. It went forward, right?
It went forward, yeah.
So bubble went this way.
Yeah.
Okay. Is there anything else happening here?
Well, let's see. It's accelerating.
It is accelerating. Ooh, should we?
Because the bubble's telling you it's accelerating.
So so it's accelerating, and the acceleration is always in the direction of our net force,
It's right.
right? These two cancel out. This is the only one that's pointing that way then, right?
Yep.
So my force net is going to be that way, which means my acceleration is going to be that way too.
Very well done, I'd say.
Yeah, and our bubble points that way. It all checks out, right?
Yep.
We're not accelerating over here, right?
We're just, sitting there.
No, right? Acceleration equals 0. And we know that because our forces,
Cancel each other out.
they cancel each other out. It works out really well. Nicely done. Okay. What's next here? What forces are acting on the bubble cart while it coasts to a stop? So I push it, I let go, ooh, now it's coasting. And that bubble goes backward.
Oh, the bubble goes backwards.
Bubble goes back.
So they should make an attempt at the free body diagram. Didn't we just do this the other day?
Yeah.
So you should, don't cheat, don't look at what you did before, but can you do it again?
Can you do it again? And if you can't remember what you did, try to think through it logically. What's going on here? What do we know about the direction of the acceleration? Force up the fuck. Okay. Now, it's slowing down. Why is it slowing down?
Force of friction. That's right.
Right? Ooh, high
Make your
hands.
hands nice and toasty.
High hands. Okay. So the force of friction is going to be pulling it back that direction.
Always opposes motion.
The opposite direction of the motion, and it was moving this way, so it's going that way.
And the bubble's going that.
And the bubble's going that way, so which direction is their acceleration? It must be that way,
Yep.
right? And our force net also is that way too then.
There you go.
Sweet. Okay, what else do we have here? Ooh, this is a good one. Newton's second law shows the relationship between the force exerted on a mass and the resulting acceleration. I would like you to solve it for all 3 variables. So write down the equation, force equals m times a 3 times, and then solve it for force. Well, solve it for force.
It's already solved for us. That's easy.
Easy. And then solve it for acceleration. And then solve it for mass.
Go ahead, you can do this. Come on, come on.
Go ahead and do it. While you guys are doing it, I'll start over here. Okay, force equals m times a. And I'm going to put net right here. What does net mean?
Means the total. It's you add them all up. It's the sum.
So that's why we had to look at all the different directions of the arrows.
Yeah.
Okay, so this one's already solved for the F. Sweet. And then this one wants the A, right?
Yep.
How do I undo this multiplication? Opposite of multiplication is
Division.
divide by m, cancel
Boom.
that.
Done.
A equals force net divided by mass. Now I'm gonna just start flipping it like this on you guys, because I like
It's all the same
I like
thing.
to read left to right.
Yep.
So I just put this over here, that over there. Okay. Now this one over here we solve for m. How do we undo multiplication? We do the same exact thing.
Miss Moore, this is so easy. I'm bored.
So easy.
Boom. Done.
Okay. So now you have the three equations. You just have to figure out what the question gives you, what it's asking you, and you know how to plug in the numbers. Let's see what we got here. Let's do number 3 together. Number 3, yes. Okay. The net force provided by the propeller of a 0.75 kilogram model airplane is 17 newtons forward. What is the acceleration?
Which equation are we going to choose?
So we're trying to find the acceleration, so we're going to use this one right here.
Yeah.
And let's write down what it says. The net force provided by the propeller of a 0.75 kilograms, that's mass,
Yeah.
model airplane is, the net force is 17 newtons
Forward.
forward. What's the acceleration? Let's just plug it in. Okay, my force net was 17 newtons divided by 0.75 kilograms.
That's 17 newtons forward.
Oh, thank you. Forward. Okay. You have to keep that direction in there. Uh-oh.
Oh, where's the calculator?
Plug in your calculator. Tell me what you get. I don't even remember putting those there on Friday.
Is that the one with the batteries?
Yeah, we're good. 17 newtons divided by 0.75, and I get 22.7. 22.71. Meters per second squared.
Forward.
Forward.
It's a vector. It has direction.
It has direction, yes. Okay. This doesn't seem too bad.
Nope.
Okay, we're gonna do number 5 together. A car has a mass of that many kilograms.
By the way, for those of you who are afraid of scientific notation, that's 1,500 kilograms. Move the decimal 3 places to the right.
What force is required to accelerate the car at 4.5 meters per second squared to the east? What are we trying to find here?
The force.
Force, okay, so that means we're gonna use this equation right here.
Yep.
Okay, so my units are, let's see, 1.50 times 10 to the 3rd kilograms. I have these marks from right here. This is how many cups of water I drank on Friday, just to make sure I was drinking enough. Okay, all right, so kilograms, that's mass. And what did you say? You said I move this 3 places to the right if I need to?
Yep, that's 1,500 kilograms.
Right there. Okay, that looks so ugly. 1,500 kilograms. Okay, this or this, same thing. A mass of that many kilograms. What force is required to accelerate the car at 4.5 meters per second squared to the east? I just plug it in.
That's just boom to boom, just mass times acceleration.
Ooh, I'm not gonna
You're not gonna
have
have enough room up there.
Thank you, sir. And let's see, 1,500 times 4.5. And you know what? I'm gonna do this twice so that way you guys can see how I put in the scientific notation. I get 6,750, 6,750
Newtons.
east. Now check out how I put it in scientific notation. I would say 1.5. Now I have an E button, so I just push second in the E. And then I'm 3. There it is. That's the exact same thing as 1.5 times 10 to the third. And I multiply it by 4.5. Boom. And I get the exact same number. Okay.
All right.
East. That's my answer.
This stuff is really simple. They just need a little practice.
Yeah. And so that's what you're going to get. I'm going to post some of these questions to Canvas on the next, right below. Okay? All right. Good luck, you guys.